Hello friends, welcome to my YouTube channel. Friends, today I am going to discuss about inter-process communications. So, what are the various methods of inter-process communication? What is inter-process communication in C, C++, in Unix or Linux platform? And I will be describing a message queue, how message queue communicates, how to implement a message queue in C or C++ language. I will show an example here and I will describe message queue, all the parameters, in-depth discussion of message queue. So friends, before starting, let's show you I have already this is my channel. I have already uploaded more videos related to C, C++. You can view all these videos. These are related to this only. So, friends, let's start today's topic. So, let's first understand what is inter-process communication. So, inter-process communication is the mechanism provided by the operating system that allows processes to communicate with each other. So, friends, I will be describing it with an example here. So, I already have a message queue example. So, I will be describing a message queue example with source and everything. So, I will be showing you source, how to implement the message queue, and how to message queues will talk to each other. So let's first understand inter-process communication is the mechanism provided by the operating system that allows processes to communicate with each other. Now, what is process and how two processes will communicate with each other? That is, this is called inter-process communication. So here I have one binary. I have one C binary. I have started this C binary here, and these are same system to terminals I have opened. So if I see these, so I have searched this binary. So it started one process. You can see this is the PID of the process ID. So this is how the process is created. Now if I do yes. So you can see in my system there are multiple, so many processes are running. So now if two processes want to communicate with each other, so what are the various methods of communication? This is called inter-process communication. So let's first discuss what is the various process of communication. Then I will be showing an example of message queue, how to do message queue programming. So so the different approaches of implementing inter-process communication is here is pipe, then socket, file, signal, shared memory, and message queue. So I mean, you already have used socket, file, and all this. I mean, nowadays, if you browse anything like you are browsing an HTTP URL like Google URL or something like that, there you are using inter-process communication like socket. That is socket communication. Whatever you do over HTTP or HTTPS, basically it's a client. Browser is a client, and server end it creates a TCP socket connection. So these things I will be describing with examples, with the real C, C++ examples, how socket communication happens, how to create pipe and two pipes communicate with each other. So this I will be describing in details. So here is just an overview of all these things. So a pipe is a data channel that is unidirectional. So in C, C++ you can create two pipes, and two pipes can communicate to different process, and you will create a pipe in two different processes, and both pipes can communicate with each other. Socket, you already know examples how socket communicate, client socket, UDP socket, TCP socket, SCTP socket. So all these sockets I will be describing in next videos with examples. So this is how the socket, like HTTP connection is a TCP socket. So this is how socket communicates. So socket is a medium of inter-process communication. Again, file, you know that you can write in computer everything is stored in a file, so you can write to a file, another process can read from the file. So these were two processes, writing and reading on a file, they can communicate with each other. This is one way of inter-process communication. Then comes the signal. So Unix has C++ has functions for sending the signal, broadcasting the signals. So one process can send a signal to another process can read these signals. So this is another way of inter-process communication. And shared memory. Shared memory is where two processes will share the memory. So this is how there will be shared memory is the memory that can be simultaneously accessed by multiple process. So two process will share a part of memory, that is a shared memory. So one will write to shared memory, another will read from the shared memory. So both will be using a segment of memory common to both processes. So this way both process will be communicating over shared memory. So these things like pipe, socket, file, signal, shared memory, these I will be showing examples with examples. And today I am going to show you a message queue example. So what is message queue? So multiple processes can read and write data to the message queue without being connected to each other. Message queue are stored in the queue until their recipient retrieves them. So this is how it's a C program where you will call a function which will create a message queue. One process will write to the queue, another process will read from the queue. So this is how the message queue is created. So this I will be showing examples. So these things, these shared memory, signal, file, socket, and pipe. These next videos I will be uploading these examples, real time examples, all this. So message queue. Let's understand how what is message queue and how it works. So let's see a message queue example here. So here I have two programs already written. One is message queue server, another is message queue client. So let's see the message queue server first. How to create a message queue in C++. So, so if I go by the theory, so msgget function, this function need to call to create a message queue. Now, while calling this msgget function, there are various flags like IPC private, IPC create, and IPC cl. You can call o create or exl. So these flags you need to pass while creating the message queue. msgget. So I am showing you an example here. So this is the header file. This is IPC interprocess communication.h. This is the header file. Unix C provides, GCC provides for uh, using message queue. So IPC.h we have to include. Then I have to define a message queue key. It's an unique key across all processes. So when I will create a message queue with this key is unique. So whoever will access this key, he shall be able to read and write from this queue. So this is what message queue. So here I will be showing a small example. It's a server which will create a message queue and it will read from the message queue. And another is client which will be accessing the message queue and it will write to the message queue. So here I have a message key. So this key is common both across both server and client. So here I have another structure I have used, which I will be using for writing data and reading data. So this I will be using for writing and reading data. You can use any text like character also you can use. uh, so anything is possible. So here I will be using a structure for writing in the message queue and reading from the message queue. So here is the msgget function. This function is used for creating the message queue. So the variables, the parameters of msgget is you have to pass the key. So this is my message key, so I have passed the key. Then create, IPC create I have called. So what this will do is, if the message queue already exists, it will not create a message queue. It will just pass the queue ID. And if it doesn't exist, if this message queue doesn't exist, it will create the message queue and it will return you the queue ID. So it will not provide you any error in this case. So if it doesn't exist, if it failed to create the message queue, then only you will get the error. But if the message queue with this key already exists, you will get the queue ID. So this queue ID is the unique value which will be used for reading and writing data to the message queue, reading from the queue and writing to the queue. So here is the server. What I will be doing is, in the main process, I will just connect, I will call this connect function to create a message queue and get the queue ID. So I put the queue ID as global here. So this queue ID I will be using for writing. So msg receive for receiving from the message queue and msgsend for sending to the message queue, sending data to the message queue. So let's see here. So the values, possible values, the error codes that are possible, access a message queue exist of the key. So if you use these variables, instead of IPC create, if IPC execl you use, so there are possible values. If the msgget function fails and returns -1, it will set the error number indicating the error. So there are multiple errors possible, like access a message queue exists of the key, but the calling process does not have permission to access the queue. So if there are permission issues, there are functions to set the permissions to access the message queue. So if there are permission issues, you will get access this error code. So here I have already set p error. So if any error will come, it will print the error. That related error it will print. So here e-access error you can get if the return value is -1. Then E exists, a message queue exists of the queue message specified by IPC create and IPC execl. So if you use these two flags combination, then if the message queue exists, then you will get this error. ENOENT, no message queue exists and key and message queue did not specify IPC create. So if you use this flag, this error value is possible. So these are the possible error values if the msgget function call fails. So this is the use of msgget function. So now see what is the to send and receive the message. So msg send is used for sending the message and msg receive is used for receiving the message. So both these cases you have to pass the QID, message QID that you received while msgget. After calling the msgget function, you will get the message QID. This QID you have to use here for sending and receiving the messages. So message p and message flags. So here I already showed you how to receive the message. Let's first understand how to send the message. So client also I am doing the same only, because I know this the message key. So I have used this connect function. Here is my client. So I have used the same function to get the QID. So the message key is common across both. If the message already created, it will return the QID, existing QID. If it is not created, it will create a QID and it will create a message queue and provide the QID. So once the QID is created, so what I am doing here, I am writing it to the message send. I am calling the message send function to. I have already created a text like this is the text starting message queue count. So here I will be sending a count, incrementing the count every message. So this message I will write in queue, this client will write in queue, and server will read from the queue. So these are two different processes communicating with each other. One will be writing in the queue, another will be reading from the queue. So this is just for example. I am showing you a text message, writing a text message and reading a text message. But in real scenario, what will be there? You will be sending some data, or sending some data, or sending some proprietary messages to another process, and based on that proprietary message, that process will take few actions. So this is what the message queue will do. So here message send, it will write the data that I have filled, it will be writing it in the queue. And here is the flag. Here you have to mention the size of this message, and here is the flag IPC no wait. It will not wait for the, it is non-blocking message send. So if you set this flag, it's a non-blocking message send function. So this will keep writing. Once it will create the message queue, it will keep writing the message in the queue, and the server will be reading from the queue. So I have two programs already written, already there. So I have opened two windows. Here I will be running the client, and here I will be running the server. So, so how to compile? So let's compile this. So I am compiling this msg client.c, and I am creating this binary. So this binary got created, message queue client binary. So here I am compiling the message queue server. So here also my binary got created. So let's start the message queue client first and see what happens. So I have started my message queue client. Let's see here. The to see the message queue, you have to type this IPCS. So you can see here, it created one. This is the key of this message queue. One message queue is already created. So this is the key of the message queue, and it's writing some messages. You can see here 9 messages are already written to this queue, and these many bytes are utilized. So if I run it again, you can see that now it's 36 messages already written. So it's a so while it will be writing, if someone will not read these messages, it will keep in the message queue. So now let's start the server. So see, after starting the server, it read all the messages one by one, because I am reading it in a while loop. So it read all the messages one by one. So now whatever it is writing, it is reading from the queue. Now if you see, now I stop the server and I run the IPCS again. See you that all the messages are read and removed from the queue. Now it is again writing to the queue. So now if again I start the message queue server, so the message queue will get cleared and it will read the message. Now I stop the client. So the message sending message is stopped. So it stopped reading the message. So here one thing to check is, now if I IPCS. So see here, no message, no bytes are there, but queue already exists because the server is already accessing this queue. So the queue exists, but no one is writing to the message queue because server is already running, but client is not running. So now I am stopping this server also. So this server is stopped. Now let's see how this. So what is it's doing is just reading the message queue. it's in while loop. It's a blocking function. So it is reading from the message queue. Then if the text is not null, because I have used the same structure for writing in the queue and same structure I am using for reading from the queue. So if data exists, it will read from the queue. If it is not null, it will print the value. Then it will go next and it will read the value and print, read and print. So this is how it will continue. So here I am starting the server again. Here I have started the client. So these are two independent processes. So this is one process, this is another process. So they can talk to each other. So it can send the message from one process to another process and it can talk to each other. So this is one of the inter-process communication. So if it stops sending message, it stops reading the messages. So this is one inter-process communication example with message queue. Now let's see one more thing about message queue. So we see three functions like msgget, msgsend, msgreceive. So these functions msgreceive can also return an error while reading the message. It can return high -1 instead of success. So if it is -1, these are the possible error values you can get, error numbers. Similar, this EXS, fault, IDRM. So this message queue was removed. If message queue is removed and you try to read from this message queue, so these are the possible errors you can get. So these are the values. So there is another function msgctl. This msgctl is used to control the message. So you can get, so msgctl has these things you can do with msgctl. You can remove the message queue. You can set the permission of the message queue using the msgctl, or you can see the statistics of the message queue. So this msgctl is used for the can set these three flags and can control the message queue. So here is the structure. This message queue DS structure is used in message control for various functions. So int cmd, here you will pass what kind of command you want to use. Whether you want to remove the message queue, you want to set something, set permissions in the message queue, permissions of the message queue, or you want to get the statistics of the message queue. So based on this command value, it will do the action. So here is the message queue ID DS structure. I will show you a simple example how this message control function function is used for reading the statistics. So here statistics related things I already showed you. So there are the two things. So this is where I have defined the message queue DS structure. So this is message queue DS structure. By default is IPC.h file it is defined. So this message queue DS structure I have mentioned, and here I have called the message queue control function. I have passed the message queue ID and I have read the statistics of the message queue. And here this structure it will store the statistics. So statistics values I can print here, like message queue bytes, what is the message queue byte set, what is the message queue number, what is the number of messages stored in the queue. So all these things I can print here after reading the statistics for this specific QID. So let's recompile this and see how it's working. So here I have recompiled the changes. So here I am starting the message to client again. So you can see that it's incrementing the message queue numbers. So this is the bytes, this many bytes it can be used for this message queue, maximum set to this. And here it is reading the how many messages are there in the queue. It's reading from the statistics. Now let's start the message queue server and read all the messages and see what happens. I read all the messages from the queue, so there is nothing in the queue now. So it's set to zero now. So the statistics, this is how the statistics of the message queue is read from the server. Now I stop this, and again you can see that the it's incrementing the number of messages in the queue because no one is reading from the queue. So again, I start the message queue server. It read all the messages from the queue. So there is showing zero. So this is how the message queue control works. You can use other features like IPC, remove, uh, like removing the message queue and see how things work. Once you remove the message queue and try to write in the message queue, it will throw an error. So friends, this is all about message queue. Hope you like this video. If you like this video, please don't forget to subscribe to my channel. So here is my channel. Here I have uploaded few more videos related to C C++. So don't forget to subscribe to my channel and like share this video. So here you can subscribe. Once I upload new videos, you will get a notification here in your YouTube channel. So friends, thanks for watching my video.